Winding resistance test. Winding resistance test is done in Resistance Test tab. In this test, by injecting DC current into CVT secondary and measuring voltage through the input and dividing voltage by current, DC resistance or R measured is calculated. It should be noted that in the software, there is only one row in the test table by default. If the CVT has more than one taps or cores, by pressing Insert Rows, it is possible to add as many rows as necessary and test any of them. To perform this test, the test current and time must be entered in iTest and state time fields in a state settings section respectively. The current limitation specified for this field is 32 amperes, but 1 ampere of current is usually enough for this test. About rows of the result table, it should be noted that if Show Resistance Column option in Test Object is checked, 3 more columns including RNOM, RDEV, and Assessment are added to the table where RNOM and RDEV refer to the nominal resistance and the difference between RNOM and R correction respectively. If R correction is lower than RNOM, the assessment is passed, otherwise it is failed. After entering the information, the wiring needs to be done in accordance with the picture. It should be noted that it's possible to magnify the picture by double-clicking on it. In this wiring, first the IA1 and IB1 current output phases are jumpered, and IA2 and IB2 phases are paralleled with the capacitor box. Here, IA2 is connected after connecting it to the positive end of the capacitor, and to the S1 CVT, and IB2 is connected after connecting it to the negative polarity of the capacitor and to the S2. The reason for using a capacitor box is to compensate CVT inductance. In this capacitor box, there are 3 1000 microfarad capacitors, and the red and black ends of the capacitor box are the positive and negative polarity respectively. To measure the DC voltage, input 1 should be connected to the CVT and a little further from the current connectors. Then, the source of the current, which was paralleled with the capacitor, is connected to the CVT terminals. It should be noted that to perform the test, it's necessary to right-click on one of the rows of the table and select Apply Test. By doing this, the device setting related to the current and the test time, as well as the hardware settings related to hardware configuration, including the outputs and the binary analog inputs of the device, are automatically adjusted. To analyze the test, it's possible to use Table View, Detail View, and Signal View. After opening Table View window, 2 states with 0 frequency and in accordance with the information entered in a state settings section can be seen. The function of the first state is to change the CT current from transient to steady state, while the function of the second state is to measure the current and voltage and calculate the resistance. If the user wishes to have access to a more thorough source of information than the table view, they can use Detail View window, performing the test and analyzing the results. After adjusting the wiring, 1 ampere and 5 seconds are entered as the test current and test time respectively, and by right-clicking on any of the rows and pressing Apply Test, the test begins. It should be noted that in Signal View section, it's possible to view the actual waveform of the current and the voltage measured by the input. By using Signal View and the recorded voltage and current waveforms, it's possible to analyze the test. Using the actual values and the recorded voltages, check if the connectors are connected correctly. After the test is finished, by selecting the row in Results section, the test results can easily be viewed. The results include VDC, IDC, RNUM, R correction, and R deviation, which refer to the measured voltage, the injected current, the resistance measured in the current temperature, the resistance measured in reference temperature, and the difference between R correction and RNUM in terms of percentage respectively. In correction factor field, the temperature correction factor is calculated in accordance with the current ambient temperature, the reference temperature, and the material of the winding. The information of this temperature is entered in temperature correction field in test object, and the R correction is obtained by multiplying R measured by the correction factor. In the end, after performing the test, if R correction is lower than RNUM, the result of the assessment is passed in assessment. Otherwise, it is failed. After the assessment, it's necessary to add the results to the report, which in equipment test is done by pressing Add to Report. Also, if you wish to add specific parts of the test to the report or edit or delete the report, add to Report cog. By clicking on this cog, the elements that can be added to the report are indicated by checked checkboxes, and before pressing Add to Report, the user can uncheck any of them that they do not wish to be added to the report. It should be noted that after every test, the test results are not added to the report automatically, and after every test, it's necessary to add the results of the performed test to the report by pressing Add to Report before clearing the test. If you wish to use a different wiring for current injection, you need to have pressed Apply Test at least once. Then check Don't Change Hardware Setting and select their intended wiring in hardware configuration and press Apply Test one more time. To select a different input, it should be noted that the selected binary input target must be similar to the default binary input target. For this, it's suggested to right-click on Input 1 row and cut the information and paste it in the intended row. To change the current wiring, it's important to set the output target of the selected wiring at IL1. There are two more notable points. The first one is that error other indicates that either there is a problem with the wiring or the resistance is too high that the device is not able to provide the burden needed for current injection. Therefore, in cases of facing this error, the user needs to examine the actual value of the current from signal view. If the current is injected from the device, but its difference with the specified current is high, the wiring resistance is too high. And if the actual current is zero, it means that the current injection path is open. In cases where the resistance is too high, it's necessary to decrease the current, and when the actual current equals zero, the connection of the connectors need to be checked. The second point is that if the measured voltage has a too high tolerance or equals zero, this means that the connectors are not connected correctly.